So, hello everyone, and welcome to Kubesimplify workshops. And I hope you all are doing good. So today, I hope you already know what Kubesimplify is because you have been attending all the workshops. If not, then Kubesimplify is a community to simplify cloud native for everyone. And we have our Discord channel that definitely you should follow because for every workshop, if you have any queries with respect to all the stuff that you have been doing, or if you have any questions, if you have any doubts that you want to ask, please join the workshops channel in the Discord. So make sure to join that and make sure to share this workshop to everyone because this will be a hands-on workshop as previous workshops. We have covered Linux and Docker fundamentals. We have then by Chad, then Kubernetes 101 I covered, GitOps and Argo CD Dan covered, and Revant covered container and Kubernetes security. Then we didn't do Kubernetes troubleshooting because I was suffering from COVID, but I have recovered now. And the Kubernetes troubleshooting one will be held on September 12th. The registrations are still on. And today is chaos engineering with Litmus chaos. So more on the cloud native chaos engineering, what is cloud native chaos engineering and all those stuff. So I hope you will be able to get a good understanding because Karthik is amazing, as a human being and as a tech person. So he knows a lot of things about chaos engineering, and he's the maintainer of Litmus as well. So you are in the right hands for learning about all about chaos engineering. So just one thing, always keep sharing your learnings, and you make sure to follow Karthik as well. Yep. So follow Karthik on Twitter, tag him on your learnings throughout this workshop, and make sure to do the workshop with him on the environments that he'll be like telling you the guidelines how to do and all that stuff. So it'll be an amazing session ahead. And yeah, I'm very excited for it and hope you have watched the previous workshop because the only prerequisite for this workshop is that you should know Kubernetes. So if you have watched the previous workshop, so you're already set, and this workshop doesn't require any prior knowledge or experience with chaos engineering. For that, you are here and you will be learning that. So make sure to follow Kubesimplify workshops, register for the future ones, join the Discord, and follow Karthik as well. So let's get started, and I'll put everyone on the screen who just joined. So hello, please tell us from where you are joining in, so that you know you all can network with each other. Awesome. So Karthik, over to you. Please introduce yourself, give a brief introduction about yourself to the community, and then you can kind of get started with the chaos engineering. Let me know if you want when you want to share the screen, and you can do that.
Sure. Thanks for the wonderful intro, Sai. Great to join the Kubesimplify community and very happy to meet you all. I'm Karthik, one of the maintainers of the Litmus Chaos project. I work at a company called Harness, which is a cloud native CAC end-to-end CI/CD platform, application platform delivery organization. So we basically started with the Litmus project about 4 years back. I'll talk you through the origins of why we started it, what was the pressing need, what is chaos engineering about, and how the project evolved from the time that we started, where it is today. Right. I'll give you a little bit of context about chaos engineering and then Litmus, and then we'll go ahead and do the hands-on lab. It's a very simple lab. We'll do a hello world equivalent in chaos engineering today on Kubernetes. So let me go ahead and share my screen and do the talky portion of um, today's discussion before we delve into the lab. Is there any question or is there any thing that you specifically like to see as part of this particular lab? If there is something that you would like to understand specifically, you want something added in the agenda about chaos engineering, feel free to add that in the comments, add that in the chat. So we'll probably address that as we go. Right. Cool. With that, let me just share my screen. Just give me a minute. Okay. I hope my screen is visible. I hope my screen is visible. You can just give me a quick shout out. Second, does this look okay?
Yeah, that looks fine. It's visible. Perfect.
All right, that's good. Okay, so as with anything else, we'll go through the W's, the what, why, who, when, and where, and also about the how, and I'll introduce you to the principles of chaos as we go. So this official definition of chaos engineering is something that there's a lot written about chaos engineering. First of all, there's a lot of literature that's available on the internet. It's not new. The practice is about, let's say, a little over a decade old. 2010 or 11 is when it really kicked off. Right? And this term chaos engineering was coined around that time. It became mainstream around that time. Right? It is effectively injecting the controlled faults into your environment, injecting turbulence voluntarily, so to see how your applications behave, to test the resilience characteristics of your applications, especially for distributed applications. So the concept of distributed applications or services is not new. Of course, the microservices and containerization wave has taken it to another level. But chaos engineering predates or sort of really precedes its entire cloud native paradigm or the revolution. It started at a time when cloud native was just getting born, right? So chaos engineering as a principle or as a discipline is very much applicable to so-called legacy infrastructure and applications, things that you would call monoliths, etc., as much as it is applicable to today's cloud-native, microservice-based, container-based, Kubernetes-based infrastructure and applications. The official definition, I just threw a few words at you. I said controlled fault injection. I told distributed systems. I said voluntary turbulence. I told about resilience, testing resilience characteristics. I'm sure a lot of this resonates with you. You might think of it as coming under the broader testing bucket, right? So chaos engineering as a philosophy still falls under your um, testing testing category or testing part of your software delivery lifecycle. Right? But there are some subtle differences between what you traditionally associate with testing. Testing, you would say performance testing, functional testing, unit tests, integration tests, end-to-end tests. Right? Some of these things are a little different from what you would do as part of a chaos test. So there are two schools of thoughts. There is a school of thought that believes chaos is always about experimentation, it's always chaos experiments. Whereas there's another school that thinks, okay, it is also a test, right? There are some expectations from it, and I'll just call it a chaos test. It is not always exploratory. It's not always that you learn new things from the experiment. You have certain expectations around what should happen, and then you go ahead and validate it. The tools that are built out to carry out chaos engineering can be bent any which way. You could carry out the pure experimentation model of chaos engineering, or you could use it as some kind of a testing tool, just include it inside of your pipelines and do fault injections as part of your automated tests. So we'll talk about that a little more as we go. Just to continue on that history thread, right? So I was telling you that 2010-11 is when chaos became mainstream. The pioneers of that effort or that process was Netflix, of course, along with a few other organizations, bigger organizations which were fairly mature in terms of what their software delivery practices were, such as Amazon, Salesforce, Google, etc. But really, you would associate chaos always with Netflix, primarily because of the tool that they made open source called as Chaos Monkey. So that you associate chaos with a monkey, right? It can go ahead and do a lot of monkey in their own, so to say. And the reason why they made this tool and the reason why they took chaos engineering so seriously is because they had a few incidents in their own environments. So long before Netflix became this online streaming platform that it is today, it was more of a video sharing platform with its own um, data center that they were maintaining in their own, in their own labs. They had their own buildings where they had all the infrastructure being maintained. And once upon a time, they had a database failure, something that they took quite some time to recover from and bring their services back for consumption. And that's when they decided that they will migrate to the cloud, just to make their operations easier. And AWS Cloud was then up and coming, one of the most earliest and fairly established cloud platform at that point of time, with all its virtual machines based on EC2 and disks with EBS and shared file systems with EFS, etc. So they moved everything onto the cloud, and while that helped them with their operations and with their scale, they were really scaling up fast. They also used that opportunity of migration to go ahead and create some best practices in terms of how they would test the resilience of the infrastructure in a more proactive way. So they created Chaos Monkey, which would go and randomly kill EC2 instances that were hosting their services and then check how the system stood up to that fault. If there was a problem, things went down, how quickly could it be brought up? And then slowly from, ensuring the recovery times were less, they ensured that they would not go down at all by adding in enough redundancy, and things went from them. They also introduced a lot of other things. You might be reading about the strict circuit breakers and all these things. So that got added on. That became an allied discipline along with chaos, circuit breakers and stuff. Round about the same time, you had this field, or a designation called as the SRE that was coming up. Site Reliability Engineers might have heard of this, which is one of the most um, valued roles in an organization today. Google was one of the earlier ones to advocate site reliability engineering. They said, take the software delivery principles and apply it to operations, and what you get is SRE. Right? And they wrote this very famous SRE book that I'm sure all of you know about. They talk about the golden signals there, how you should do observability, how you should carry out releases, how you should do deployments, how you should test resilience, etc. So chaos engineering became a very important tool, or an important skill set in that profile of an SRE, and it sort of grew from there, right? And they were really the custodians of the chaos experimentation that someone would do in an organization. And around the same time, we had the the concept of testing in production that came up. So this I'm trying to talk about distinct um, um, paradigms that came up around the same time. They are all very much interrelated to the common thread. The common thread is about improving resilience, ensuring that we have 596, 99.599 resilience. What all you do to ensure that, right? You try to make your applications microservices based and move it to the cloud. You do that kind of thing. What is popularly called as digital transformation today, when your organization are doing it, Netflix was trying to do it a long time back. And then introducing chaos engineering to proactively test, and then this testing in production that came up is about how to maximize
Karthik,
that. Yeah.
just a second. So
Yeah.
there is some disturbance and in the voice.
Oh, I see.
I
There's
don't know.
a there's some rain that's sort of hitting the asbestos sheets outside.
Oh, okay, okay, okay. Yeah. So
I
the
think
volume, like your volume is like a lot of background noise is too much, and your volume is less. So I'm not sure what can be done.
um, okay. Let me see if I can split the audio to something else.
Can you try using the Max microphone in the settings? Yeah, so there's the rain going on, and no one can stop the rain. So that's why there is a background noise. I was thinking that he's on the Max audio, but actually he's using headphones audio. So let's see. Let him join back. So I hope you understood the concept of chaos engineering at least. And chaos engineering, yes, there were some questions. So it is being used in production by many organizations. Chaos is actually like creating a trouble in your infrastructure, and then analyzing it, and then you will be like you'll be able to find the bugs before it actually happens. So there are a lot of aspects to when you define chaos engineering. So Karthik is back, and Rain is
Is
still
this
there,
any
but let's see.
is this any better?
Yeah, it's a bit better if I like if you can just start, then I think the audience can tell if they can hear you well.
Okay, I'm sharing my screen again. As well. Okay, let's take off from where we left. Sayan, please stop me if this is still back. I think we were talking about testing in production. All right. So there is this whole movement of going ahead and carrying out tests in production. We said chaos engineering we're going to do, inject pods in a controlled manner and try and verify the residence characteristics of your application. But where do you do that testing and what kind of environment will you do it? Initially, when Netflix proposed the principles of chaos, they said we should do it in production, right? And that's because of this whole test in production movement that was happening around that time. Their reasoning was nothing can really simulate um, the the dynamism that you would find in a production environment. In prod, when failures happen, you have black swan events that can happen, disasters, DDoS attacks, and things like that, natural disasters, and all that kind of stuff can happen, of course. But there are also prod problems that get built up over a period of time. So in production, when something really breaks, that is been in the works for let's say the last few days. So you have a chain of events that lead up to an eventual disruption of a service, right? So that's something that is very difficult to simulate in a very sanitized, controlled test environment or a QA environment. And the amount of traffic that you would get in the production environment is also something that's not very easy to reproduce in a controlled test environment. Of course, that is mitigated to a certain extent by a great set of synthetic load generators available today. You have Locust, you have K6, and you have whatnot. And there are also tools with replay capabilities which can actually catch traffic and then simulate those patterns for you as part of a synthetic load. So some of the load generation part is still something that you could use today, but the overall dynamism that you would see, dynamic nature of the production that you experience is not something easily replicated. So they said you should actually go and test the resilience of your application in production because otherwise you'll never get that kind of a situation or an environment at all. Right. This was taken well by some people, some folks who really accepted that worldview, and there were some other folks who said, okay, that's something that we cannot do. We will eventually get to that point, but we will do a lot of testing of internal environment, which is mostly the case as well. Most of the organizations today prioritize chaos engineering in pre-prod environment before they actually get to prod. But the original principles of chaos actually tells you to do fault injection in prod to see how things happen. And because you're doing fault injection in production, there are a lot of um, um, tools and lot of capabilities you expect to have in order to mitigate the extent of impact. You want to do very, very controlled faults, ensure that blast radius is not high, that's the term they use, blast radius. Blast radius can be different ways. How many downstream services do you impact, or what is the extent of your user traffic that is going to get impacted. There are different ways of measuring the impact of the blast radius. But typically, from an execution standpoint, you are trying to look at isolating it into a particular service, into a particular region or a zone or a cluster, or a node, things like that, right? So that is how you control blast radius. So you have to have the ability to control the blast radius. You have to have the ability to abort your fault injection in case something goes out of hand. And how do you find out that something is going out of hand? You actually need to have observability. You need to have your Grafana dashboards, your data log, Dynatrace, or Sysdig, or what have you, or Neural Lake, and things like that to monitor your applications for specific characteristics and really look at how that is changing when the fault injection is happening. And if there is a threshold that you anticipate that beyond which things can go very bad for the users, then you have the ability to abort the experiment. Ability to abort it manually as well as auto abort capabilities. There are a lot of such things that are needed when you have to do fault injection in production. You need to have the right guardrails. You need to check the health of your system before you're actually able to inject faults. So all these things that we're talking about, controlling blast radius, being able to do pre-flight checks, being able to do some post-chaos remediation actions, being able to validate hypothesis using your observability, doing it in the right kind of environments like doing it in production or doing it in environment, doing it in an environment that closely resembles production, choosing the right kind of scenarios or faults to carry out your experimentation, being able to record all your information, record the results of the experiment, act upon it, form the right hypothesis. All this is part of your chaos engineering discipline. Right? These are all different aspects or subtasks involved in your chaos experimentation world. And one of the things that differentiates it from traditional testing, when you take functional or performance test management, is when originally conceptualized, chaos engineering is a lot about learning about the system when sudden and unknown failures happen. So there's a lot of learning involved, whereas in traditional testing, there's a very specific expectation of how the system should work. Whereas you have a very predefined view of how your application works when you're injecting a particular fault, where with chaos engineering, you're open to learning about the system more by looking at various aspects of your application function. You're looking at some CPU attributes, you're looking at how your latency is getting changed, you're looking at what impact this has on some other downstream application. You're looking at whether you're receiving the right notifications when a particular fault has happened or when an issue has occurred. Do you get your information to send to the right persons at the right time within the right window for them to act upon it? How easy is it is able to resolve it? A lot of this is part of your experimentation process. Your incident response mechanisms, whether you have the right documentation to be able to address a certain issue. All this is also part of your all this broad natured view verification activity is part of chaos instead, whereas a test is generally not so broad in its outlook. And that's one difference. The other one is with testing, there's a lot of emphasis on the how. How does the service work? How does the application work? Whereas with chaos engineering, you're not so worried about the how part of it. You're actually more worried about the what or the impact part of it. Right? You have SLOs against your services, and those SLOs might be defined in terms of many SLIs. For example, you have mean time to recovery, you have a certain error budget bound that you're looking at, you have mean time to detect MTTD. These are all things that a person who is doing a chaos experiment would be concerned about, whereas someone who's actually testing the system as a developer or as a QA engineer is more focused about the how part of it, right? Whereas the SRE always has the end user in mind and is looking at these SLOs and is looking at the what part of it. That's a very loose way of differentiating between testing and chaos engineering. We'll talk about some of that more, and I'm open to taking questions to articulate this better. Right. So this is about the context. We've talked about the definition. We've talked about the history, how it came about, and the context. And when I said history, we're only talking about what Netflix did and what Google did, how testing in production came into being, how chaos engineering came up, how SRE as a role developed, etc. We talked about all that part. We have not talked about how it has evolved in this last 10 years and where it stands today. Right? We'll get there very soon in the next slide. We'll talk about that. The why part is quite self-explanatory. Outages are very common. I've mentioned the names of some organizations there. These are all very famous organizations known for their software and the software practices in the way they operate and deliver code, etc. One of them is a bank, for example,
Karthik,
Wells Fargo, right? Yeah,
one thing. So you are sharing. So we can only see one screen, which is what, why, who, when, how.
I'm still there. I'm still there.
Okay, fine, fine. Was just checking.
I've just come to the why part of it.
Okay,
I'll breeze through the who, when, where, and how,
okay, fine, fine,
right?
fine.
And then we'll get into the next section.
Perfect.
Just wanted to set the context.
Okay.
Cool. And the why part, like I was saying, is quite self-explanatory. Outages are very common. So Slack, Wells Fargo, AWS, British Airways, all these companies are put there because they were recently in the news. And I say recently, it could be last few months to last couple of years, where they had major outages, which impacted a lot of people's productivity. And of course, these organizations did take a little bit of a reputation hit at that point of time, but they were extremely good with how they recovered from it, right? It's not always about being resilient all the time. I mean, being reliable all the time. There's a slight difference between reliability and resilience. Reliability is about always being available. Resilience is about, okay, you are going to go down, maybe, but how quickly am I going to recover and ensure the service is back up, right? So these organizations were very good with this part. But still, despite being such amazing organizations who actually practice care, things can still slip through the cracks, right? And the impact of an outage is not just dollars; it's a lot about reputation and then the impact that follows, right? And then there's this thing called Murphy's law. You might all be familiar with Murphy's law. It basically says if anything can go wrong, it will go wrong. Right? If there are X number of failure points, you can anticipate at some point of time, some point in the lifetime of that particular service, as long as you run it, if there are X failure points, X failures will happen uh, for sure. Right? That's the market, so you need to be prepared for it. And of course, apart from being always available and improving resilience characteristics, chaos engineering has a lot of side benefits. For someone coming newly into the organization, they're able to learn about the depth of dependencies in their software. They're able to get a 360-degree view of how the software is built and deployed and maintained and observed. Incident response becomes better. You probably put more automation, you put in better processes to ensure that your incident team is not burnt out when the actual incident happens. Because when you do chaos experiments, it's like a fire drill. Right? The persona who were traditionally carrying out chaos experiments, based on our discussion about the history, it's always been the SREs, right, or the ops folks who carried out the chaos experimentation because they used to do it in production, or pre-prod environments, this penultimate staging environment just before we deploy in prod, right? Those kind of environments always managed by SREs. That's where the chaos was happening. The people who were handling it were traditionally the SREs, and they were the ones who were the torchbearers of this chaos engineering practice in the organization. The when and where part, we talked about it. We talked about testing in production, why how some people are doing it in production, people doing it in pre-prod environments. When part is typically as part of your release activities. When your software is mostly baked, ready for deployment, that's when people would do chaos engineering traditionally. That is changing. We'll talk about that. And the manner of conducting these chaos experiments was using an event called as a game day. A game day is basically when everyone gets together, they decide that on this particular environment, we are going to do this fault. This is our mitigation strategy. This is what we are going to observe during the fault. And these are the stakeholders from whom we need to buy in to actually carry out the chaos or the fault injection. Right? They would get together and do it. And that's how people carried out chaos experiments. It's not something they do it every day. They used to do it once in a while. Um, that's how many organizations still do it. I'm talking in past tense, but many organizations continue to do this. They carry out game days periodically. They have some organizations even have events, fun events called Fail Fridays. So they basically go ahead and carry out fault injection end of the week, right? Things like that. So Netflix and all the other organizations like Amazon and Google and Salesforce and everyone else who were the early pioneers created the principles of chaos, which is how they said chaos should actually happen. So this is a Git repository with a web page. You can see that they're talking about certain principles. They say you have to define the steady state, you have to simulate real world events, you have to validate your hypothesis around the steady state. You have to do it in production. You have to do it continuously, automate it because you don't want to inject human errors in the process of experimentation. So automate it, and run it fairly continuously, and do it in a controlled way by minimizing blast radius. Right? These are the real goals or principles of chaos, which hold true to this day. Right? It's just that we've added some more principles around it or some more ways of doing the same thing in a cloud native world. So this is the first slide, just to give you a lot of context and history. And I'll very quickly go through what has changed over this last few years, especially since cloud native has taken center stage and Kubernetes has become the real universal substrate for running all your services, right? There are newer architectures coming into picture. Many organizations have broken down their erstwhile model of building, deploying, and maintaining their services. They've made it more decoupled. They've got separate microservices. They've got this multiple containers, and each container is going to be a specific function. They've achieved separation of concern. Right? What this causes is that there is an increased surface area for failures. Right? The dependency tree is more complex today, and there is a greater surface area for failures. Right? That's something that has happened. Um, a lot of people are doing migrations from a prior deployment environment into Kubernetes-based deployment environment, or they might be moving from on-premise to cloud. They might be moving from one cloud to another cloud. They might be going from um, let's say a VMware vCenter-based environment or a EC2 based environment into a Kubernetes based environment. They might be using PKS, or they might be using, if that's on-prem, or they might be using EKS or GKE or AKS or any of these environments, right? And because they're doing this migration, they need that confidence that things are going to run there. So there's a lot of failure testing that's happening there to build that confidence in as part of their staging and migration process. So that's one thing that's happening. And the number of targets or subjects that you will, number of services that you would subject to chaos is much more. So there's something called this services pyramid. At the base of it, you have your hosting infrastructure, right? It could be a bare metal or it could be a cloud. Then you have Kubernetes on top of it, Kubernetes control plane services and all the other services that run inside your nodes, your kubelet, your Docker daemons and other things. And then you have a lot of tooling that you pull in from your cloud native landscape for service discovery, for monitoring, for storage, and things like that, right? And then you have direct application dependencies like databases, message queues, etc. Then you have your application on top of it. Your application itself is composed of front-facing, user-facing services, your middleware, your backend, and things like that. So if you look at this pyramid structure, there are so many moving parts inside of your today's deployment, Kubernetes-based deployment environment. Maybe there is some part of it outside Kubernetes as well. Maybe you have some managed services in Azure or AWS that you're consuming, but within the Kubernetes. You have some pods that's consuming RDS or pushing to the S3 bucket, right? So that's there as well. You have all these third-party services as well. There are multiple moving parts in your deployment environment today, and failure to any of these can have a certain impact, which you should be prepared for and should know about, right? And tune for resilience. So the number of experiments that you would do would exponentially also increase. There's going to be a big blow in a big blown up number in terms of total experiments that you're going to do, because the number of entities that can fail and cause a significant impact is more. Right? That's one thing that has happened. And the other important part about so many different services and targets is each of them, because it's a microservice, has its own upgrade path. It's basically going to get deployed individually. right? It's not always done as a one shot. It's going to be independently upgraded. You have the concept of GitOps. In a previous Simplified session, you might have talked about GitOps and RCD and how your services can be upgraded in production based on changes made into Git, etc. So that's how all these code is being maintained. Today, everything is infrastructure as code. That's how you're managing it. Your applications are all being stored as manifests inside a Git repository. In fact, your cluster tunables are also being stored in some form as Terraform templates or something inside your Git repository. Changes to this gets reflected on your actual deployment environment, and this is all going to happen independently at a very fast rate. There's a 10x increase in terms of upgrades that people are releasing or deploying not just once every few months or every few weeks, they're doing it every day. So things are getting changed very quickly in your deployment environment, and you don't know what new variable that is bringing in into your system, what new vulnerability it's bringing into your system. You will find out only by doing chaos or fault injection continuously in your system and validate that, right? So the need for continuous automated chaos is there much more than it was there earlier. So that's one of the other things. And the other important factor is the the developer experience. When I say developer experience, I'm not only talking about the application developers. Everybody is a developer today, right? They're doing some kind of development. It could be the SRE or the QA team or the actual application development team, or somebody who you would call as being in the DevOps function. People who are managing pipelines and things like that, right? So for all these developers today, there is a fairly homogeneous experience when it comes to what they do, right? They have Git repositories, everything is declarative. They're able to manage everything as YAML. All that is there today, right? So you would want to get the same experience for doing things like chaos engineering as well. Your security policies are defined in a very declarative way. Your resources, how much you're going to consume, what are your limits, all that is declarative. Everything is that way. So when you're doing testing and fault injection, you would also want to bring that into this ambit, into this purview, right? Make it homogeneous. Uh, Make your chaos tooling just another Kubernetes app. Have the same, treat it the same way you would treat any other application. And when you're defining your tests, what is the fault you want injected? How long do you want it injected? Where you want it run? What is it that you want to validate when the fault is being done? All this you would want to define in a declarative way, and then get it orchestrated, get this entire process of experimenting and testing orchestrated the same way you would do other things, right? So this homogeneity is another need today. So these are the things that have really changed because of the cloud native, Kubernetes native paradigm that's come up, right? And so we needed some difference in the way the tools are built and used to carry out chaos engineering compared to what was built by Netflix and others like Chaos Monkey and those kind of tools. Don't really fit into this scheme of things or requirements, and there's a need for us to come up with some newer methodology for this, right? So I've set the stage for Litmus. So Litmus was born about 3 4 years back. Um, in order to test OpenEBS, which is another Kubernetes native storage product or solution. But then it acquired a roadmap of its own, and it became a separate project in CNCF, which provided a sandbox for us, and it became incubating. Fairly big community got built around it. Many organizations are contributing to it, etc. And this Litmus precisely addresses these requirements for doing chaos in a cloud native manner. Right. So we'll talk about how we are doing that. We will basically take up the architecture of Litmus briefly, and then we'll probably step into the lab. I see that we've spent around 30 minutes talking about the history and how chaos engineering has evolved and what are the need of today and other things. I can take some questions before we delve into the Litmus architecture, or if there are any comments and things like that, I'd be happy to take them.
Yeah, like a few questions are there. Like, is chaos engineering used mostly in production or rather on test stage environment?
Yeah, I think it's predominantly the latter today. We talked about Many organizations not having that innate confidence to be able to test them prod right away due to many reasons. One of the main reasons being all this digital transformation that they're undergoing. Many organizations are still maturing their eventual deployment environments, their production, and they want to test what happens when there are failures in a pre-prod environment, even before it sort of gets deployed into production. A service is curated in a pre-prod environment for quite a while with different chaos tests, and then you have certain policies or certain successful test coverage that you achieve based on which you promote it into eventual production. Chaos does happen in production in organizations that are really at a very, very advanced stage of operations. They're very mature. They do game days in production, but they do it in a very, they don't do it in a very um, frequent manner. They do it as part of a game day, which is carried out once in a while, right? But most of this everyday chaos experimentation and testing happens in the pre-prod environment. In environments that mimic the production as much as possible, that's what we call as staging and pre-prod. So that's where mostly it happens. So people want to ensure that they gain some confidence before they go and do the same faults in production. Okay, that was one. Any other questions?
No, I think you have covered a good amount of topics on chaos, the evolution from traditional systems to doing more cloud native way, where you have increased number of microservices, more third party tooling, increased number of the Kubernetes components itself that can go wrong. So that's where the traditional chaos stuff has changed and migrated to the cloud native way of doing things, and that's how the tools, especially like Litmus, has evolved to be more cloud native way of doing the chaos experimentation, building out the workflows, obviously that you'll be telling now. So by now actually you should be like people who are watching, you should be familiar with the principles of chaos engineering, and you should be knowing what exactly chaos engineering is, the practice of injecting the chaos into the systems and creating a failure and trying to find out what happens. So it's basically a few steps that we define, like defining a steady state. So we define a steady state which is there, then we define the hypothesis, then adding the variables as per the real world scenarios, then try to disprove the hypothesis, and we try to continuously do that, but always make sure that the blast radius is minimum, like the question which was very good, like are we doing chaos engineering in production? So obviously if you are doing chaos engineering in production, you have to take care very precisely of the blast radius, because if you do not think of that, then you do not want your your customers to see a downtime just because you are doing chaos experiments. So it has to be done in a very controlled manner, and that's where like the community is headed to, that's where the tools are headed to do it in a controlled manner. A couple of more questions have come in. So can disaster recovery be dr testing, like how it is different from the
Yeah.
dr testing?
Yeah, chaos engineering is a way to do DR testing. I would put it that way. Um, it is very similar. When you do DR tests, generally you're sort of preparing for some kind of a catastrophe, right? Some kind of a black swan event. And you traditionally expect their blast radius will be fairly high when that happens. So most of the DRPs, as they call it, disaster recovery planning catalogs, involve taking down an entire region or taking down an availability zone, taking down an entire cluster, things like that, right? So that is one of the chaos experiments you would do. But you could also do chaos experiments at a much more fine-tuned or fine-grained, granular level. Um, Add just 20 milliseconds of latency, or like just create about 50% of packet drop on a network, and then see what happens. Right? That is as important as taking down your cluster and doing disaster recovery testing. So, disaster recovery testing can employ certain chaos experiments, or you could frame it like this: disaster recovery testing can use tools like Litmus to carry out certain faults, right? But the overall principle of chaos engineering encompasses disaster recovery testing also as part of it. Is not only restricted to that, I would say. In fact, Google has this program for disaster recovery testing, which is very interesting. I forgot the name. I'll probably share that as we go along. Where they themselves recommend users to, of course, they do it themselves as well. Google Cloud offers the 6.9 capability, but they also recommend users to carry out zone failures and things like that. So you could use tools like Litmus to carry that out. It is very allied to disaster recovery testing. I hope that answers.
Yeah, thank you for that. And a couple of people asked like whose responsibility it is to perform chaos engineering in a particular project or systems.
Yeah, so we talked about the who here, and they said it's really the SREs most of the time, right? People who are um, really looking after the systems, maintaining it, you're maintaining your deployment environments. But that's been the case for a long time. Things are changing because of these reasons, as we said. And if you look at this, if you read these points, you sort of get a sense that, okay, needs a lot of developer involvement, not just the SREs, right? Because the more you shift your chaos, the more you push it into pre-prod staging and then your QA environments and your pipelines. The people who are doing that also is going to change. And then there is this philosophy of chaos first principle. That's what we're calling it here, democratization of chaos engineering. Chaos first principle means thinking about chaos experimentation even as you build out your design and then your product, the initial versions of your product, not just waiting for it to be fully baked and then you do the chaos, because at that point of time fixing issues found from chaos engineering will be that much more costlier. So Adrian Cockcroft, who is basically the advocate for resilience engineering at AWS, who also was at Netflix earlier, um, sort of popularized or really seeded this chaos first principle approach. With this, people are even doing fault injections as part of dev testing. So it's really democratized now. That's why I use that word. The responsibility or the onus for chaos experimentation is with everyone, and you think about it right at the time of your initial implementation and design. Earlier, it used to be the SREs. Probably that's how many organizations continue to function today. But in the cloud native chaos way of doing things, you sort of bring everyone along. So it's really a shared responsibility.
Cool. Yep, no more questions. We can continue.
So I'll try to not get too much into the architecture part. We can always revisit this after we've done the hands-on lab. You'll be able to relate better because you would have seen things there. But this is like a 10,000 foot view of what the tool provides, Litmus Chaos does, right? You have something called as a chaos control plane, composed of a dashboard and a server and a DB to store state, which helps you to carry out chaos, manage your chaos. When I say manage chaos, there are different things that come under it, under that chaos management. It's about finding the right target to do chaos upon, scheduling it to be done at the right time, visualizing or tracking the progress of an experiment, helping analyze what an experiment has resulted in, right? How your systems have behaved, ensuring that the tests that you created or the chaos scenarios that you drafted is stored in a as a golden copy in some place so that you can use it and modify and run it whenever you want to do it. All this is part of the chaos management, right? That's done as part of the control plane. And then the execution plane is where the chaos business logic actually happens. Your fault injection, your hypothesis, automated hypothesis validation, and all the experimentation, real experimentation happens in the execution plane. So Litmus supports different kinds of execution planes, predominantly Kubernetes, but it can also do faults against targets that are not Kubernetes related. For example, GCP or Azure VMs or VMware VMs, on-prem, I mean, bare metal machines or things like that, right? You could count those as valid targets for chaos as well. And then there are some artifacts associated with the tool. There are metrics that come out of an experiment, which you can use to instrument your dashboards. There are scenarios that you create in a YAML format, which you can go push somewhere into a stable storage, into some repository, right? Like that's what we call it your hub. That's your artifact source. You pick experiments from there, and you push new experiments that you create into it for future use, etc. These are the artifacts associated with the experiment itself. So this is what the tool and its ecosystem looks like. This is a very high level view of the same thing. Maybe it comes to 1,000 foot view from 10,000 foot. So the brown or the beige box that you see here on this left hand side is the control plane, and what you see as the green box is the execution plane. Different deployments here. So Litmus is a Kubernetes app in itself. It is a microservices based application itself. You could deploy it and manage it the same way as you would do other applications. So you basically, as a user, would come in, identify your target, add your cluster where you want the chaos to happen, identify some microservices within it. Basically, there is some asset discovery that Litmus helps you to do. Identify your microservices that you want to do chaos on, build out your scenarios, and execute it. Right? When you execute it, your control plane pushes that scenario spec into the execution plane. There is a agent sitting here which will actually run it, and there are some deployments that help you in carrying out the part. Right? You can see there is an operator, the workflow controller, etc. These are some of the deployments sitting inside the execution plane which help in carrying out your chaos scenario. Right? And one of the other features of Litmus is that sometimes um, a single fault. Today in Litmus, we map a fault with an experiment. A fault is associated with some hypothesis. So fault plus hypothesis is one experiment, right? Sometimes you might want to do complex scenarios. You might want to build up multiple experiments together in some form to be done one after another, maybe to happen in parallel, right? To cause that actual downtime effect. Sometimes when your outage happens, it's a result of one or more components going down in different ways. Maybe there's one node running to full saturation, there's no longer any space to run any new services on it. At that point of time, there is an eviction that happens on another cluster, so your pod needs to be rescheduled, but you cannot schedule it. Right? That kind of situation, if you want to create, you might want to do two experiment, one on the node and then pod sitting elsewhere at the same time in parallel. Right? That gives rise to the concept of a workflow or a scenario, which is basically one or more experiments clustered together in some form, right, in some order. So the tool allows you to do that. You can create scenarios, and they're all executed in your execution plane. Then there is a result that is stored in your control plane as to how the experiment ran, what happened to your hypothesis, etc. Right? These are the different components. We will relook at this after some time. And this is some detail on how the agents can be structured in Litmus. When you run a chaos experiment, you can choose to run the experiment in the same cluster where your control plane resides, or you can choose to do it in a remote cluster, which you've identified as the place where you want to run the execution plane, right? So of course, you will be able to discover the local Kubernetes microservices wherever your agent runs and target them to do the chaos. Or you could be using this particular execution plane to run the chaos business logic to target something that resides outside Kubernetes. You just pass your cloud secret, your cloud access credential form of secrets to your experiments, and they will be able to consume it and do things like bringing down EC2 instances or bringing down VMs or causing some kind of resource consumption or cause some kind of network latency inside of your EC2 instances or VMs that are, of course, outside of your cluster, right? Depending upon what you have access to or what is the permission service or permissions you've given, you'll be able to target it, right? That's this thematic basically shows the different kinds of agents that are there. And this is basically your deployment diagram, how your Litmus is going to be structured. These are the control plane components split into different deployments for you to view. There is a front end, which with its own deployment and service, right? And there is a config map that it consumes. And there's an auth server. There is a MongoDB. There is, we run it as a stateful set. There is a server based, which is essentially a GraphQL based server, which is used for carrying out your orchestrating your faults. Is really the brain. And on the execution plane, you have the workflow controller to say in a particular chaos scenario, these are the several tasks that are there, and these are the tasks to be executed, and it executes them one by one. One of the tasks happens to be the actual core chaos fault injection spec, which is viewed and operated upon by the chaos operator. And then there's a Prometheus exporter. This is the agent that speaks to the control plane to relay instructions to be picked by the workflow controller and the operator. There's something called as an event tracker, which helps in chaos injection based on specific events. So it can trigger a chaos scenario based on specific events happening on the cluster. So we will. This is how it looks, right? And at this point, I'll probably jump into the lab, and I'll come back to this slide. That is how the execution actually happens. What is the various things that happen as part of chaos experiment run? How the control flow is essentially, that's what this diagram talks about. And all these numbers that you see are actually this is representing the sequence in which things happen when you run a chaos experiment. So we will be able to appreciate this better once we've done a little bit of setup and we've run our first workflow, right? And then we'll come back to this slide and we'll talk about what exactly happened when we ran the experiment. And if time permits and if there is interest, we'll talk about some low-level details of the architecture. And one thing that I would like to highlight before jumping into the lab is what happens as part of the chaos experiment. So Saim summarized well some time back when he said you have a hypothesis, you inject the fault, you validate the hypothesis, and then based on that you take the next action, right? Whether it is a pass or fail, and then if it is a failure, you go back and you do your RCA and you fix something. You fix something either in your application business logic or you fix something in your infrastructure. Maybe you don't have the right timeouts that you've configured. Maybe you don't have enough nodes. Maybe the resource quotas have not been set properly. These are all infrastructure things, or there will be a genuine bug in your app which you're going and fixing, right? Things like that. So that is the flow at a very high level. If you put that in a little bit more detail as to how Litmus does it, you can actually see that user provides some inputs about what they want to target and what they want to validate it. And the experiment essentially does a series of pre-chaos checks to see whether chaos can be carried out on this target, on this cluster or no. We don't want to do chaos in a degraded environment and further escalate existing problems, right? We want to check for the health. These are all guardrails. You look for optimum functioning, and then we go ahead and launch the resources to carry out the fault. And all this that is being shown in the flowchart happens inside of a pod. The entire experiment execution happens from inside of a pod that is launched as part of your experimentation process. So when you go to your chaos dashboard in Litmus and say this is the scenario you want to run, it gets executed from within a pod that is launched at that time. Right? And we basically go ahead and inject the fault. We keep at it for as long as we want, right? That's what we mean by the inject chaos iterate step here. And then we stop the fault after a prescribed duration. Then we do post chaos checks to see what state the application is in. We have an expectation of what it should be at the end of the experiment, and then based on whether it is in that state or no, we go ahead and pass the experiment or fail it, right? And all along, just as you do pre and post chaos checks, you can also continuously run some probes. Let's say you want to hit an HTTP endpoint to see whether it is alive. You want to run a PromQL query to see whether the metrics that are emitted by your application are deviating in the right manner, or whether if at all they should deviate, are they within the limits, or whether everything is great. Let's say you want to run some kind of a data integrity check as you're doing your fault injections. You might want to run some commands, some scrub operations you might want to run in the background. These are all possible to be done using what we call as probes. And they also contribute to whether your experiment passes or fails, right? So this is what happens as part of the experiment execution. Within the experiment pod, all this logic gets played out. Right now, let me come to this very interesting playground called as Killer Coda. Thanks, Simon, for introducing this to me. We used to have Catacoda earlier, but I don't think that's available free of cost today. So I think this is the alternative. There is a repository that I've created, which I will share probably on chat. I'm not sure if I have access to the on this chat.
Yeah, you can
All
paste
right.
that in the private chat.
What's the private chat? Is it okay?
Yes. So here is this workshop. I have pasted to everyone, and I'll also paste the link to the playground.
Yeah, it's killercoder.com.
Yep.
When you go to playgrounds, you'll actually see Kubernetes. It says 1.24. You can probably select that. There are
Yep, I
other
have sent
options.
both of these.
Yeah. All right. Let me get back to sharing my screen.
And also, when you are sharing the Killer Coda playground, you can actually minimize that left hand window so that you can get maximum terminal screen.
Sure. Cool. Is
Yes.
this okay? Cool. I
Yeah,
think
can
we
increase
have.
the font. Yeah, increase the font size.
Sure.
Command. Yeah, you can do by this, or command plus should also work.
Is this better?
Yeah, that is better.
Cool. I think we have about 9 minutes. I don't think we'll take that much time, but anyways. So we've got two nodes, one control plane and one worker node, and the control plane is also untainted to schedule pods, which is great. These are minimal nodes as you would expect in terms of resources for Killer Coda. So we'll probably install a version of Litmus where we've not specified resource requests and limits so that we don't have problems in being able to schedule them. Right. So we've got the steps here, very simple steps really. I'll probably augment this repo with some screenshots and other things later. So the first prerequisite for us before we set up Litmus is to have a default storage class. Killer Coda doesn't provide us one. So I just added the steps here to set up a dynamic local PV provisioner that we've got from Rancher. It's essentially going to use the local path to provision storage. We need it for the MongoDB. That's part of the control plane, right? So you can run these commands to set up the local PV provisioner as well as patch the storage class to become default. Of course, you need not always have it as default. You can go change your Litmus installation spec, provide the storage class name, but it's just simpler to do it this way. Um, I'll probably go through it a little slowly so that you have time to follow along. If you're stuck at some point, please let me know. And we will do what we'll do as part of this demo is install Litmus Chaos and execute a simple chaos scenario, the hello world chaos scenario, if you would like to call it that way, which involves a pod delete. Now, the experiment might sound very innocuous. Pod delete is something very simple. Applications are going to recover obviously because Kubernetes is going to bring up the pod. But there's a lot of benefits that you would get from even this supposedly simple experiment. We'll talk about it as we go. And we'll do this pod kill on a web application, a very simple web application called as Potato Head. I'll just apply it and you'll be able to see that it's just a okay. There's probably some error in the deployment spec. I just put it down a few minutes back, line 4. Let me open it up. Okay, let's see what this is. Converting YAML to JSON. Let's check this out. Probably bring this entire thing onto a editor here. Okay, the spec is built out. I'm hoping that we don't really have any YAMLs here. Yeah, there is a small misalignment in indentation. What's name and namespace is fine. I don't think this is really needed here. We probably label app load service. I think that's what it might be. I'm just going to add the label here. Please make this change as you are doing it as well. I hope we are all familiar with Kubernetes, so I think this should not be much of an issue. So I hope this YAML is going to work fine. Yeah, we've got the application created. I go ahead and commit this change here as well, so that you're not impacted when you're trying it next time. I hope I got it right. Now we have a new namespace created. As you can see, it's called demo space, and we have an application that is running here. Just a single replica pod. We have it as a single replica for a reason. We'll talk through that as we go. And we've got a node port service that exposes this particular app. It's 32598. That's my node port. It might be different in your case. If you go to this 3-bar menu on the right hand side of your Killer Coda screen, you can actually open up the traffic here. So let me go ahead and do that. We provide the port that is there, and we've got the access to the application. Right? This is just a simple hello service. This is Mr. Potato Head. Each image for the head, arms, legs, etc. is coming from. It's a different image that your app is putting together and rendering like this. That's what it is doing. It's a very simple web app. We'll go ahead and kill the pod that's running here, right, and see what the impact is. That's what we know what's going to happen, but we will lay that out as part of the experiment. So let us look at the next step once the application is set up. So these are all part of the prerequisites. We've opened the port and we have the application access. Now we'll go ahead and set up Litmus Chaos, and we are sourcing the manifest from the Litmus Chaos / Litmus repository. So this is the repository. Of course, you have helm chart as well, but in the just for sake of simplicity, I'm using kubectl, and we've picked the manifest from here. So there is a 2.12 latest open source release. We're picking it from here, and we are using this manifest called Litmus 2.12 without resources. Right. So that's what we're going to use, and I've provided the raw link here. So let's copy this and edit. And probably after doing this, I'll give a pause to see if we are all um, doing well and we're at the same point of the demo. So this is going to set up your control plane first. So in this particular diagram, the deployment spec, we have the control plane and execution plane. When you install this manifest, you will only have this red color dotted box coming up. You have the front end, the auth server, the GraphQL, and the Mongo database alone. It's going to come up initially, right? And it's going to create the RBAC as part of the install that's necessary for the service account attached to these control plane components, right? So let's check what has happened. This is the namespace. So this is getting created. Our Mongo DB is running. So our local PD provisioner is working. It's great. And this needs to be running in order for us to run the other components. The auth server and GraphQL server that you're seeing here have init containers wait for successful bring up of the Mongo stateful set replica. And once the connection is established, it'll actually spin up the main containers, right? And this is the front end, and that's going to wait upon successful bring up of the server. I think all of them are in running state right now. So we'll look at the services, and no code is what is the default, but that's probably not what's recommended for your actual um, test environments. You would do well to set up ingress, or maybe you might be better to set up load balancers, etc. So this is just for simplicity. We're just using no ports here. So I will select the front end service and do the same thing that I did for access. So you have the chaos center that's coming up. And I'll probably pause at this point, and I just like to check if we're all good in terms of installation of the app, the storage provisioner, and the Litmus chaos control plane.
Yeah, please drop a thumbs up in the chat if you have reached till the stage that Karthik, has explained, at least till the UI of Litmus Chaos Center.
Just note that you have this 3-bar menu. It's not very conspicuous. It's next to this timer where you can open up the ports. This is also where you can adjust the font size and add new terminal windows and things like that.
And the repository is also pinned comment in the chat.
I hope you've been able to take this renewed manifest of the application. The previous one had a syntax error. We've modified it as a few minutes back.
Yeah, I can see thumbs up, so I think we can.
Awesome. Cool. So now that you're here, before going ahead and logging into the Chaos Center, let me do a watch on the pods that I brought up. The reason why we want to do this is because the execution plane components are now going to pick up automatically. You see only the control plane. When you log in into the Chaos Center and create your first Chaos project, your Chaos project is nothing but a workspace for you as a user to carry out Chaos operations, do the Chaos management from. And once you create your project, your execution plane is going to be brought up locally. So in this diagram that we talked about earlier, there's something called as a local agent or self agent, we call it. So this is something that is brought up auto-magically whenever your first project gets created, right, on the same cluster where the control plane resides. Now, whether you would want this or no can be tuned via an environment variable. Sometimes people don't prefer to use local agents, they only want control plane running there. But for the sake of the demo, we're just going to use the self agent for our chaos. And that is the default mode as well. We're going to break up the self agent automatically. That said, let's watch it. You're actually going to see a few more pods get added here. So let me go ahead and log in. The default credentials are admin and Litmus. Admin and Litmus are the username and password by default. So you can go ahead and log in. You can change it always by changing the secret in the Litmus namespace. And it asks for a new password. I'm just going to skip that for now and leave it at admin and Litmus. So this is the chaos project. You can see it's called as the admins project. you can go to settings and add newer users. You can come to this user management. You can create a new user where you have their username and password provided and provide it to your team members, and they can log in. Once they are in your platform, once they are within the instance, you could actually build a team where you could invite your team members into the your project, your workspace in a specific role as a viewer or as an editor or as etc. They have different permissions in terms of what they can do once they come into the project. And each user is going to have their own respective projects into which they can connect their own agents and execute the chaos. And so that's about the user management part. So we are logged in as an admin project. So we don't have any chaos scenarios. It basically tells you that there's nothing running. But it says there's one chaos delegate. But one chaos delegate is what is the self agent that is automatically brought up when we did the project creation. The project creation happened when we did the login. Right. So if you go back to the terminal, you can see there's some new parts that have come up. There's a subscriber, there's a workflow controller, there's a chaos operator, there's an exporter, and there's an event tracker. So these are the components which form part of our execution plane that you see in this diagram. We said the chaos business logic or the workflow execution happens through these components, right? So they're all available now locally for us to use. And it takes a few seconds to connect with the control plane to establish this connectivity between your a subscriber and the GraphQL server, the main chaos server. It takes a few seconds. Once that is done, you will have it shown up as an active agent. Right? So this is available for us right now. This is the one that's going to take our instructions to carry out chaos in this cluster. The other useful concept that I'd like to introduce you to is the chaos hub. So this is the artifact source. If you look at our first diagram, this 10,000 foot view of chaos that we started with, there's a chaos hub. We said this is the artifact source from where we're going to choose experiments and where we can push experiments into, right? So that's the chaos hub. This is also hosted separately, visible to you from within the chaos center dashboard. It's also available as a separate website just for user interest, where there are different categories, you have different experiments, and there is some statistics against them. These are the number of times these experiments have been run by the Litmus community. We're just getting some call metrics to track the popularity of the experiments. You can obviously see the body one is the most popular. We'll come to why that is so. Right? And this in turn is getting rendered, all this information and all these experiment templates that are stored within these cards. They're all coming from a Git repository in the Litmus chaos org. Right. So coming back, so we have the chaos hub from here. You can view the same kind of things here. We have the chaos experiments. You have all these experiments that you can pick and run. And you also have some predefined chaos templates for illustration purposes. If you just want to run something where you install the app, you're going to run the chaos, you're going to see the result, all complete workflow, you can use this. We're not going to use this today because it takes up a little bit more of resources on your cluster because it's launching an app with multiple microservices. The version of Potato Head that we've used in our hands-on demo today just has one deployment, but the one that's there inside the platform is like a multiple services multiple microservices Potato Head, which will not use for right. So we have all these components that have come up. I leave the watch going as it is here, so that we can see what newer pods are getting as we go along. And I'll come to this chaos scenarios part. Now we've seen the settings screen where we talk about user management. There are a few other tabs here which we'll talk about later. I've come to Chaos Hub and I showed you that this is the artifact source. So all these experiments you can pick them and you can construct a workflow and you can push the workflow also into the hub to construct, to use a ready-made scenario. If you don't want to construct it newly by picking experiments, if you've done that before, you can push the completed scenario into your hub and use it for future purposes as well. I showed you the case hub and the delegates. This is the active self agent. Now let's come to the scenario screen. So this is where we are going to construct our scenario, our workflow. The other workflow is the other name of chaos workflow is the other name of the chaos scenario. Scenario is felt more appropriate, which is why we've got this name. There are different ways of scheduling a chaos scenario. We'll see what are the different ways. When you said schedule a new chaos scenario, it asks you where we need to run it. If you had more delegates connected here, more chaos agents connected here, local ones or remote ones, you would have an option here. When in schedule chaos scenario, you would have had more options, radio button, like where you want to carry out the chaos. Right? I'm just going to select the self agent here. And after that, you can choose chaos scenarios in different ways. You can select a pre-defined chaos scenario template. You saw that there was one pre-existing template. That's not what we're going to use. You could select some templates that are local, not yet pushed to hub, but it's when I say local, it's in the MongoDB. It's not into your gone into your hub. That's your Git repository. It's just there in your MongoDB. You can store a template, and these templates are generally created by cloning an existing or a prior chaos run. I'll show you how that can be done, but we don't have any workflow runs here to clone from and use as template, so it's not an option for us. There's an option for you to upload a YAML file, which maybe you constructed by hand. Maybe you created it earlier, you downloaded the scenario and you modified it with your own tunables, you modified the parameters, then you're uploading it, that's support as well. So the option we'll use today is the third one. I just wanted to use this because it will give you an idea of how to construct the scenario. And when you say, I want to create a new scenario by picking experiments from the hub, it will actually show you different hubs from where you can pick. Right? Today, there's a default hub that comes upon installation, but you can actually connect a new chaos hub from a new Git repository, from a Git repository that's either public or private. If it's public, you just provide the URL and your branch. If it's private, then you need to provide your access tokens or SSH access tokens with the right read permissions for you to be able to pull the content of the repository and render that as an other hub that will come up here. And when you create a new chaos scenario, you will be able to choose that hub as well, if that's what contains experiments of your choice or something that you built. And with Litmus, not only can you use existing experiments, means experiments that have been provided off the shelf, but you can also construct new experiments using an SDK. We'll probably touch upon that very briefly towards the end of our workshop. So let's select this third option, right? And we'll go ahead and name it something. I'll call it as potato chaos, right? There's some description that you can provide. Ignore this. This is basically to say where you want to pick your images from. And I'm going to say next. I'm going to add a new chaos experiment. I hope I'm doing it slow enough for you to follow along. So you can click the new chaos experiment here. You can filter for the experiments. There's a pod delete that you can select. That's the one that we're going to use. This pod delete is appearing to you under various categories. There's one under generic, one under Cassandra, etc. So these are different variants of the pod delete checks with the different hypothesis validation and checks. The generic pod delete is the vanilla one. This is going to kill a pod, and the pre and post chaos checks associated with this test are only to see whether the app that you're targeting was running in good state before you did the pod, and it is in running in good state after you finished with the pod, right? They are the only simple checks. But we'll add more validation into this. We'll add more hypothesis into this. I'll show you that. So I've just filtered for pod delete, and I got the generic pod delete, which I've selected. Click done. And there is this button here which actually asks you to edit the experiment, right? You need to select the app against which the pod delete needs to be carried out. So let's click this pencil button here. And the moment you go in, you are entering a submenu where you are being asked about the applications that you want to target, or the microservice that you want to target. And the way we do that is by this triad of namespace, kind, and label. You need to provide the right values here to zero in upon the deployment that we want subjected to chaos, which is this hello server. Right? So I have deployed that in demo space namespace, and it's of kind deployment. So I have the right label here. The values that you saw before this app equals to nginx, there are some, these are some pre-filled default values. No, you can select the demo space namespace, select the type, the deployment, and then you have the deployment here with the right label, right? So this is what we're going to use to filter our uh, microservice. This is one way of doing blast radius control. The same experiment can actually be performed by not giving any of this information, which is when it will randomly select any pod within your demo space namespace. But this is a pointed way of saying this is exactly the deployment that I want, subject to default. I'll go to next. When you go to next, it actually tells you what is the validation that we want to do. It asks you what is the probe you want to add. Let's add a simple probe. We'll add an HTTP probe. I'll call it as a potato head availability check. That's the name I'll give. The probe type is HTTP, which means I want to keep hitting the potato head endpoint to say whether it is alive or no. Let's assume that this was a more complicated application, some e-banking application or something like that, and you are trying to consume it. You want this to be always alive, right? So we're going to make a check to see whether it is always alive. So we're going to do an HTTP probe. There are other type of probes which we will talk about later, or you can refer to the documentation. And we're going to do the probe in continuous mode. We're going to keep checking. You have various options. Sometimes you want to do a probe check only during the chaos period, or you only want to do it maybe after the fault, or you only want to do it before and after the fault as some kind of a guardrail. To do a continuous means this will be carried out through different phases of your experiment. We'll give some default values for this. I'm just going to give some simple timeout and retry intervals and things like that. Let me just give one retry. Let us be very strict about, very aggressive about our availability conditions. Right? There's something called stop on failure here, which we've set to false, which means if the test is, if the probe has failed, it will not kill the experiment, it will just allow it to flow. And you can actually set it to true, in which case, in case of probe failure, the experiment would end with a failure, right? We're going to give it false, and then we have to provide the URL. Now I can provide this URL, but I actually noticed that with Killer Coda, there's a lot of latency in being able to validate this from within the cluster. So I'll provide something that's accessible inside. We'll provide the service IP or the service name, right? It is called a hello service. So this is the name I'm providing. HTTP :/ hello service dot demo space. This is the FQDN fully qualified domain name of the service within your cluster. Hello service dot namespace, that's the demo space, dot svc dot cluster dot local, and this is exposed on port 9000. So I'm going to provide 9000 here as well, and I'm just going to skip some checks and provide HTTP response timeout. We're going to make a get call. We're going to provide a double equal to as the criteria, means we are looking for this particular response code. We want a 200 OK all the time. I just walk you through the probe configuration. Once again, I've just given a random name. I have selected the HTTP probe type. I've given the mode as continuous. I've provided some simple values for the probe execution, timeout, and the number of times we will retry before we give up and call it a failure. I've just said one retry. And probably give a very aggressive polling interval of, let's say, 1 second. And the interval between retries. Let's say you failed the first time and you're going to retry once again. What is the time gap between retries? That's also 1 second. I'm just making some dummy values here. And I've set the failure flag to false. I've provided the service name. I'm just let me just paste this on the private chat as well, so that you're able to use it in case you need some help there. So this is essentially coming from here. You can actually see, let me take another tab and run a service command. So see here. Yeah. You can see minus n demo space. That's the service. You can see it's called hello service. and it's exposed on 9000. So that's what we've provided here. Hello service dot demo space dot local. Right? We've got, let's add the probe. So probe is available right now. Let's go to next here. There's nothing much to tune. This is about how many times you want the particles to happen. I just want it to happen once. So I'll provide the duration and interval as the same thing. If you provide larger duration and a 10-second interval, let's say you're going to be repeating the particles until you hit the chaos duration, total duration, right? We just want it to happen once. So I'm just going to give 10 and 10 here. That's the other change we are making. I go to next. This is some advanced configuration for us, which we will not touch upon at this point. So I'll just say finish. And I'm also not going to clean up the chaos resources that are going to be launched as part of the experiment, because I just want you to I want to show you some logs and a few things. So I just leave it as it is. I go to next, and this is a place where you provide weightage to the experiments. This is in turn going to influence the residence score that you would get at the end of the experimentation run, scenario execution. This is more useful when you provide more experiments as part of the workflow, where you can provide you can use this as a way to tell the importance of your workflow and how much weightage it has to carry in the eventual residence score. Right? For now, we just have one experiment. I'm going to pull this slider to the rightmost to give all points. Next, and when I click next, I have the option to schedule it just once now, or I can set up a repetitive execution as some kind of a cron syntax, right? I'm going to select this option to schedule now and once. I click next, and then you get a summary, right? If you just take a look at this YAML file, the most important part is probably right down here. You need not do this as part of the run, but if you're interested, you can just open it and scroll down. You see the line number 197, which is the chaos engine. This is the core chaos resource we are going to create. You can see that all the options that we selected are here. We are saying app namespaces demo space. We are saying that there is a label that we're going to seek out for this deployment kind, and we are using a service specific default service account to carry the experiment. These are the options we selected. We had just one iteration of particles, so we have the same duration and interval. And you have the probe condition here. So we're looking at the hello service on port 9000, and we are going to look for HTTP GET. And we're going to look for 200 OK all the time. We're going to do it every 1 second in continuous mode, right? So this is the specification that is there. So I'm going to click finish here. And if I do that, I can actually go to the chaos scenario. I hope you've been able to get to this point successfully. Are you along with me, or is there any question in the wizard that you need help on?
I think there are no questions. If there is
Okay.
no delay in Flickr, then we can use it in probe. There are a couple of questions. One is,
Uh-huh.
are we using the Argo workflows or Litmus specific workflow here?
Good question. So what we have right now is an Argo-based workflow. So Litmus uses an Argo workflow framework, but puts its own images to add some domain-specific intelligence there. You can see that the workflow carries some images called Litmus Forerunner, Litmus Checker, etc. So these are basically understanding the experiment spec and running them, but the tasks get executed as Argo workflow tasks.
And another one is,
Yeah, and to the previous question, there's also some native workflows that are getting built as we speak.
okay, the
Yeah.
link. So the link you sent is not working. Is there any? If there is no delay, then we can use it in probe without any hesitation. So you sent a link, right, in the private chat. So that is not
Right.
working. So it will be, I think,
Yeah,
different
that's
everyone.
your in cluster link that does not work outside,
Yeah, that
right? So
doesn't work
that's
outside.
something that that just need to be provided within the pro. You can actually see what's happening to your Hello Service app. Let me Let me go here into a watch on your pods in the demo space. You can actually see this was restarted 16 seconds ago, right? So it's actually undergone the kill. And this one is up. That's great. The application went down momentarily. I did not have a chance to show you that, but you can actually see that this pod got restarted, right? And then let's see what happens to the experiment really. And when the experiment was run, you had these few pods that got created, and now they are in completed state, right? Because the experiment execution is completed. We can very quickly see the logs of this experiment on our dashboard as well. We will just allow it to reflect on the front end in a few seconds. So you would have noticed if you were doing a watch that a lot of pods got created, some of them have been cleaned up, and some of them have been retained. So whatever is completed is retained here because we did not choose to turn on the revert schedule button, toggle button. We left it gray. We left it turned off because I wanted these pods to be there to show you some details here. But otherwise, they would be cleaned up and you would get back to what you had earlier. Okay. So you have the experiment that's running. These are the various stages of the experiment that you see here. There was a install experiment step, which actually put all the prerequisites, all the experiment templates from the hub were installed, and then the experiment was carried out. Surprisingly, the experiment failed. You can actually see this is alive, right? The pod was killed, but the experiment shows a failure. We'll see why the reason is. If you click on the pod delete here, you can actually see the logs. And as you scroll down in the logs, you'll actually see some crying smileys or failed smileys there. This is actually the probe failing. You had a continuous probe which was checking every second, but for about 15 seconds or so, this application was not really alive. The pod got scheduled, but it took around 15 seconds to become ready, during which time our check failed. So if you look at the chaos results, which is on the other tab of this screen, as you scroll down, you will actually see the continuous probe failed, and it says better luck next time. And this is treated as a failure with zero probe success percentage. Fairly understandable. You had one pod only, and it went down to 15 seconds, and your website was not available, which is quite bad. Of course, 15 seconds might be okay in terms of recovery, but most of the times this can cascade into other problems. We'll talk about that. I just want to finish this scenario because we have about 23 minutes left on the session of Killer Coda. So you saw there was an experiment failure because the probe failed. Fair enough. Our hypothesis was disproved. I thought my application is always going to be alive. I'll get 200 OK throughout my pod kill period, but that didn't happen, right? So coming back to the drawing board, what is it that we need to fix? Application is very simple. There's nothing much to fix there. So what is the deployment practice? So we had one replica, which we will now scale to two replicas, right? So I'm just going to execute a command to scale the deployment. Let me just do that from the other tab. We'll continue to monitor Litmus here. I'll just take the other tab where we are looking at the parts of the demo space app, the Hello Service apps. Let me run the scale command here. We're just scaling it to two replicas, not many more. Let's see what happens. Right. We've scaled it. Now let's see how much time it takes to become ready. It should take about 15 to 20 seconds. It's pulling the image, I suppose. I hope you're all familiar with the kubectl scale command. You can just take a look at it. I've just done a kubectl scale deploy and provided two replicas in the correct namespace, the demo space namespace. Pretty interesting that it is taking this much time to run. Yeah, it got scheduled and it's running, but you have a readiness probe there, which is waiting for the app to initialize. So this is going to take a few seconds. Then come up. You can see now this 0/1, right, which is the one that actually caused the probe to fail. During this period, it was not active. I mean, there were no other ports for the kube proxy to redirect traffic to. It failed. Right? So you can see it's come back now. It's available. So we have two working replicas. So I'll show you the other part, the cloning and the template part, which we spoke about earlier, right? I have a chaos scenario which has failed. I have the option to just rerun it. I can come to the chaos scenarios tab. So there is a scenarios, which is basically the specification, and the runs, which is essentially execution instance of the spec that you define here. You could go ahead and click a rerun schedule to rerun the same thing, or you can click on save template, which is essentially the same thing, which allows you to make some modifications and store. This is the local template that I spoke to you about. I just call it a local template, write some name like this. Not interested in the description. I don't really intend to make any changes to this, right? I just wanted to show this capabilities. I'm just going to save it. Once I've saved it, now for those who are watching, you can actually click on save template and provide some name and description, and then just save it. Right, save it is at the bottom of the screen. When you scroll down on this window, you have to save. Right. So now once that is there, I can actually click on schedule a chaos scenario, select the agent or execution plane where I want this run, and I can select the second option. Right? There's a local template. Maybe you wanted to change the iterations, maybe you wanted to change the value of some chaos tunable, maybe latency or packet drops in case you do that experiment. You can always make those small changes and store it as a local template and then just reuse it as well. Edit of a scenario in place without having to create a local template is also a feature that is coming in soon. That's something that we are working on. Let me select this local template and say next, next. I'm just going to go through the motions here because we've already tuned the experiment as we wanted. I'm going to say next and finish. Right. I'm just going to go to chaos. I breezed through this a little bit because there's no changes to workflow per se. It's just that selection of the template using the second option. When you create a chaos scenario, you're going to be selecting the second option and selecting the right template. If you don't want to do this, if you're not bothered, you can just go to the existing chaos scenario we created and click the three-dot menu here and click rerun schedule. That will also do the same thing. It will basically rerun the experiment. So coming back to the tab where we are watching the experiment pods, I mean the Litmus pods, you will see some new pods are getting created now for this instance. You can see it. You can see the name of the experiment run. This instance is suffixed by some IDs. This is going to run the experiment once again, and this time let me go and check what's happening. One of these pods, right? You can see this 4 minutes old and this 8 minutes old. One of these is actually going to get killed, and during this time, let's see what happens to your hello server, whether it continues to stay alive or no. Yeah, you can see this got killed. The first one. In fact, this is the one that had newly come up post the scale. So as part of random selection, this got killed. And it's taking some time, and your hello service during this period was alive. All right. So there could be different ways of doing the pod delete itself. For example, you can do force delete right now without any termination grace period seconds. It's like you're just going to kill it and recreate it. You can do a graceful kill, graceful pod delete where you allow for your post hooks in your application to work. If you have something written up, some routine written up that can execute until your termination seconds are honored. If you have any grace period on your deployment, that will be honored. Right. So this is about the experiment doing a kill very quickly, and we will eventually see what happens to this experiment here in the runs. So this is running. The pre and post chaos checks and probe evaluation is in progress. So this will eventually run. The expectation is this runs to completion. with either a success or a failure, most probably success because we had multiple replicas. We should not really worry. Right now, as this runs and as you are going through these steps, we'll talk about why this pod delete, which seems like a very simple experiment, is so relevant. Right, you could be using a stateful application and you could be using block storage. So when you do a pod kill and your pod gets rescheduled on a different node, it means that you have to detach and reattach your application, your storage, right? That sometimes can cost time, take time. It depends upon the storage provisioner that is there and the nature of the storage that you're connecting. So during that period, what is the impact? Sometimes if it takes too long for your replicas to get rescheduled because of storage constraints, maybe the amount of load taken up by the other replica, good replica, might increase. When the resource utilization on that replica increases, maybe you've set up some kind of HPA or something where you're going to spawn new pods thinking that load needs to be evened out, right? So that's one consequence. And what is the impact of this happening is something you might want to check. Sometimes it's possible that the application that you're subjecting to pod delete happens to be some complex application with leader followers, etc. So let's say you kill a leader pod, that means there needs to be some kind of re-election to select the new leader. And probably that's going to take time, especially in case of Kafka or Postgres, some of these kind of applications where you're basically having multiple replicas of the app running, each performing a different role. Typically, they're deployed as stateful sets, right? Sometimes it's possible that doing these pod deletes is going to cause some it's going to take some time for your pod to get scheduled. It'll be in pending state because there are too many nodes running to full capacity, and you want to identify the node with the right budget and then schedule it. Maybe that's going to take some time. So there are maybe you have a sidecar proxy, and it takes time for proxy registration for you. Let's say the pod that you have that you killed is actually making calls to Kube API server, and that's going to take some time to happen if you had sidecars, proxy sidecars, and during that period it might not be active. Maybe you have a high init delay seconds for the readiness probe to work and for you to come up. It might take some time. So there are so many sub constraints in a supposedly simple pod delete experiments, right? So this is something that's very useful for you to run and check. So this is one of the use cases. Of course, like you saw in the chaos hub, there are so many other scenarios. You can do latency injections, you can do packet drops, you can eat up resources, you can eat up disk capacities both on persistent as well as ephemeral storage. You can cause node failures. You can cause node failures in a graceful and you could bring down, you could do extreme load to simulate some kind of DOS situations. All these are possible using different tests using Litmus. So coming back to Chaos Central, you can actually see that this time the experiment passed. And if you look at the logs, when you click this node, when you click this particular pod delete node on the graph, you have this logs and results pop up. And when you come down here, you can actually see the probe passed this time, and the status is set with a bright smiley here. And the chaos result tells you as much with the experiment passed successfully this time. The probe passed. Okay, this is a very simple test, but you could be doing much more complicated probes. You could be running different kind of metric checks, could be doing data integrity checks, you could be doing a lot of other things. You could have constraints on how quickly your application has to become alive. Right? The default is 180 seconds, maybe that's too long. You might expect your application to be available much quickly. You're expecting a certain scale to happen when you kill pods. All that can be achieved through different kind of probes. And we also saw how you can create templates and run from templates, etc. Now that you have two runs, what is the analysis you can do? What is the takeaway for you? There's something called analytics here. So when you actually click that, you can see your runs being recorded. There were two runs, one failed and one succeeded, as we saw. Let's say you want to compare runs. You want to compare because you ran the same test on two different environments. or maybe you ran the same test on two different builds of your application, right? Two different releases of your application. So you might want to do some checks on how the experiment has progressed, whether resilience has been maintained, has it dropped, has it increased. So you can compare these runs here. You can actually see some graphs sort of pop up. You can see there's just one line here, but if you do it across days, you will actually have a curve. You can see the average score that you have is around 50 because once it failed and once it passed. But yeah, this is some information for you, and you can generate some reports as well from here. You can export this data to a PDF and then use it as part of some kind of reporting and visualization. So this was a very quick example of the chaos running, right? And you can see let me go back to tab one. You can actually see some of these resources get created in your cluster. You can see it will get chaos engine and chaos results. These are all the CRDs that are created as part of your experiment run. So I'm just doing this command to see these resources. So yeah, here it is. We can also see that we generate certain events. We generate events against the chaos engine resources. You can actually select the chaos engine by name and see what is happening as part of it. There are describe chaos engine. I think I gave it a name here. You see there are different events that you see. What has happening as part of each phase of the experiment, the fact that it is doing some pre-chaos checks, the fault injection, and post-chaos checks, and then finally gives you some summary. You can pull this into your observability as well. And there are some metrics that are generated, which we can also use. There's some Prometheus metrics that get generated as well, which I'm not showing in this particular lab here. So that's what we had to do. We analyzed our results and then we rerun with mitigation with scaling and saw that the desired resilience characteristics were achieved. Right? This is a very simple demo. Going back to at this point, I just want to check if you're able to do the same things that I've been able to show. Are you stuck somewhere? Is there any question you have? Any different results that you got? Or any questions about the way we are doing things here with the wizards, etc., or any of the screens?
Yeah, I think a lot of people have done it, and they have rated it as like chaos successful.
Yeah,
And
successful. Yeah,
yeah, so yeah, I think no questions, good comments.
cool. I think you'll be happier to find a lot of chaos failures more than success. You typically want your experiments to fail, and that you would achieve by adding the right pre-post chaos checks and by adding the right probes, etc., to really cause the failure. So that's what we had. That's amazing that you've been able to do this. I'll just go back to this slide and to this particular diagram, which we said we'll come back to. So you saw a few things happening as part of this demo. Let's start from the number one icon here. User came in, provided the credentials, got into the chaos center, right? Some authentication happened, and you were able to get inside of your project, and then you created a chaos workflow, and you said the workflow needs to be executed when you said click the finish button, right? That's the option 4 that's happened, and the subscriber received applied it. The chaos workflow manifest workflow resource was actually created within your environment. We have about 7 minutes still on the session, so you should be able to see the workflow. You can see these were the workflows that got created. They will get created by your subscriber as part of the operation number operation number 4. I think I missed. Yeah, I think 6, operation 6. So 4 is basically sending the workflow cred and in creating the spec and pushing it into the DB. That's what I've said here, right? Your server actually constructs, your front end constructs the YAML file, pass to the server, server updates it into the DB, and then it also pushes it to the subscriber. Subscriber creates the workflow by running the Argo API, that's the operation 6. Once that is done, the workflow controller actually picks it, that's the 7 that's happening here, and creates all the tasks or runs the tasks mentioned within the workflow, one of which is to apply the chaos engine, that's step 8. And when that's happening, your chaos operator is picking it and creating some ephemeral experiment pods to create the fault. The fault is happening here on your services as part of step 10. There's a result that gets generated. Experiment pod actually generates a result file. The result is also the source for the Prometheus metrics. And this is then sent back to the user. User is generally going to click the logs or the results tab on the graph. When you do that, the subscriber is receiving a request for these entities and it sends it. You will be able to view that on your dashboard, right? The logs and the results are sent. And right in the beginning, when you saw this is the deployment, these are the labels, these are the namespace, that is the asset discovery that is happening based on request to the subscriber. And finally, information gets uploaded into the auth, into your DB. That's the step 14, right? And then you have it for posterity for comparison, analysis, etc. So this is essentially the flow that happens in your experiment. We just went through all these things right now. And there are some details of the transfer of control within the execution plane and the control plane. All this information is available in the documentation of Litmus Chaos. So you'll be able to see that there. And we use WebSocket connections for communication between subscriber and the server. You could set up the control plane with SSL, use ingress with the right certificates, and we will use WebSocket secure in that case, right? So this is essentially what is happening in terms of interaction between the control plane and your execution plane, right? And this, what I'm showing you on the screen, is the interaction with the artifact hub. So your chaos hub is there inside of a Git repository. You have a service running or a routine running in your GraphQL server here, which is actually taking the responsibility of syncing your workflow specs inside your Git. And also, if you make changes into your Git, you get reflected on your platform. So that is the setting that you get to make as part of GitOps here. So you can actually say, this is the repository where I want to push my workflows into, and whenever you create these scenarios like you did now, it automatically get connected into or committed into this Git repository. And you can change it from there, and then you can source it from there for subsequent runs. You can also push it as a predefined template, just like the potato head here. So these are the various options that are available. I think this is the diagram which talks about relationship between the control and execution plane. What all we do, asset discovery, creating workflow, updating events. These are all the different activities that the subscriber carries out. And this diagram that I just showed you while talking earlier was how you interact with the Git repository from the control plane. So I'll probably start this point. I think we've gone through what the tool is looking like, how it functions in the latter part of this session. In the first part, we talked about chaos engineering history, context, why it is important, etc. I would just like to invite you all to join the Litmus Slack channel on Kubernetes. So you have the Kubernetes workspace. If you're in Kubernetes workspace, please join the Litmus Slack channel there. We have a community sync up that happens on every third Wednesday of every month, where we talk about the monthly release content, what new features were introduced, what bugs were fixed, what new use cases were discovered from the community, and you have the opportunity to learn from other community members and contributors. And then we have some special interest groups If you're interested in integrating Litmus with different CI/CD tools, or if you're interested in integrating it with different observability platforms, or you're interested in creating your new experiments to add to what is there in the public chaos hub, so you can let us know, and we can get people in interested parties, people who are interested in the same topics, and get together and discuss it along with maintainers. Then we also have meetups that happen on the fourth Thursdays of every month. So these meetups are more about user stories. So people come and demonstrate how they've used Litmus and what they've used it for, and things like that. Right? It's not so much about architecture and contributions and release items. It's more about how people are leveraging the platform. So you can find details of all this on the repository. So we have Litmus repository here. If you like the tool and would like to motivate the Litmus community, you can go ahead and give us a star. Um, and you can also um, come here and put your issues, whatever you're finding. This particular list is growing, but we are also addressing it, closing it very fast as well. So I think with that, I'll probably stop sharing, and I'll see if there are any questions or comments.
Cool. So thank you, Karthik, for this wonderful workshop. I think the hands-on scenario really helped, and people have tried it out, which is very good. And thank you everyone who stayed till the end and tried creating chaos on your clusters, which is good. Just a small shout out to Karthik. He had some family emergency, and we were actually planning to cancel the stream, but he made extra efforts to be here today, so a huge thanks to Karthik for that. And yeah, whatever he said about Litmus, it already has a good community, strong community behind it, and many people uses it. We also have a chaos engineering working group, which is shaping up. We kind of need to revive it. That I was talking to Karthik some time back. So yeah, go ahead in your, like, try out chaos engineering, because when you will be working in production system, you will definitely be doing some sort of chaos testing in your systems. And with the increase in cloud native systems and toolings and stuff, I think it's better to use the tools that cater all those things, all those fault injections, etc. So make sure to kind of check the Litmus community, and subscribe to, or set reminders for their monthly meetups that can give you a lot of value as well. Yeah, I know Karthik and most of the people at Litmus very well. Have met them in person a few times. They are like awesome human beings and great tech folks, as I told you earlier. So again, thank you, Karthik, for this wonderful workshop, wonderful walkthrough scenario that you created, and that will be available to everyone to try out even after that. So Killer Coda will also be available, so you can try all the stuffs out, and give a shout out to Karthik. uh, I'll just put up his Twitter. So make sure to follow him as well on Twitter, and give shout outs how awesome this workshop was. Someone was asking about the workshops. So if you go to kubesimplify.com/workshops, you can find all the previous workshops and the new workshops which will be getting added. So make sure to check them out. The latest one which will be added very soon. It is happening actually in 7 days. So it is by Lee on service mesh. So the next workshop will be like pretty awesome as well. And after that, we will do the troubleshooting workshop on September 12th, which was left last week. So it will be happening on 12th of September. So make sure to keep an eye on that. Keep following Cube Simplify Twitter, Discord, so that you do not miss any announcement, and be part of it. And yeah, try out Kubernetes 1.25. There's a killer coda scenario that I created just today morning. So you can try out free Kubernetes 1.25 as well, and see some of the latest release features, read some blogs, and try out some scenarios, and post your screenshots on Twitter. That's how we'll come to know that you tried something out. And same goes for Litmus, same goes for any other workshop. So last thing is, make sure to subscribe to the channel, share this video as much as you can, and hope to see you in the next workshops pretty soon. Karthik, anything you would like to add?
No, I think this was um, a real great opportunity for interacting with all you folks. Hope this was of some use to you. Thanks for the opportunity, Simon, to talk about fitness. Do join the Slack channels, try out Chaos. Let us know if you have some feedback. We keep receiving feedback on uh, making the product better. There are a lot of items that go out in every release. We do release on every 15th of every month. So we join in to find out what new things are uh, coming as well. And feel free to contribute anything that you'd like to. We appreciate contributions of all types. Documentation, it could be some improvements to the website, or it could be core chaos experiments, or anything to improve on the orchestration part of it. Any and all contributions are welcome and very appreciated. So please feel free to reach out on the Litmus channel or the Litmus Dev Slack channel. It's on the same workspace. So yeah, I think this was a great time. Thank you very much, Simon. Thanks to all the participants today.
Awesome. Yeah, as Karthik said, you can be a contributor to Litmus. So make sure to check the project repository, go through it, code contributions, good first issues, documentation. So everything, please make sure to check it out and be the contributor as well, because I know many people keep asking they want to contribute. So these are the projects that you can go and contribute. Start contributing easier than very big projects like Kubernetes, because there the flow is pretty, it is kind of different kind of release cycles and all that stuff. Projects like Litmus, and they they are smaller than the big Kubernetes project, so it's kind of easier to navigate through the code base and stuff, and contribute. So try it out, and reach out to Karthik. He's very reachable, and share your feedback as well. So thank you everyone for tuning in, and thank you Karthik once again. See you next time. Bye.
Thank you. Bye.